Okay. So, folks, again, you are going to see some very, very simple redox reactions, redox questions, particularly in multiple choice, that are just going to ask you which element is oxidized, which element is reduced. Please tell me in this example what is happening to sodium. It's being oxidized. So chlorine must be reduced. Very good. I want to call your attention to our first somewhat significant change from last year's AP Chemistry curriculum and this one. There are some questions in the problem set that are going to be very much like this. Here's a reaction. What element is being oxidized? What element is being reduced? And you will notice in the list of problems for Chapter 4, one of them has something after in the parentheses. I think it's number 71. It says, ignore the part in the directions about the reducing agent and the oxidizing agent. Okay? Those are terms that will no longer be on the AP exam. So I'm not covering it. I will not be on your test. And you can ignore that part for that one problem set problem. All you need to be able to do is tell me which element is oxidized, which element is reduced. Do not worry about these terms: reducing agent, oxidizing agent. Okay? So, let's do a little practice with that. This is, again, something very quick. All I want you to do is tell me in each example which element is oxidized and which element is reduced. Go. Alright, so guys, we're going to move on to the last section in this chapter, and really the main event for today, which is how to balance a redox reaction. And you might be thinking, why does this get special mention? Isn't balancing an equation just like balancing any other equation? Not really. Redox reactions, it's not impossible to balance it the way that you are accustomed to, just looking from each element left to right, but it is much more challenging. Okay, and so what I have on this slide and the next one is a list of steps for how to balance a redox reaction. Okay, and instead of just talking about what the steps mean, I would rather use this example problem and talk through the steps with an example in front of us. Okay? So here we go. Here is what the question might say. Okay, and this is something you're going to see 99% chance in free response and not multiple choice. Okay? The question would give you a reaction and say, balance the following reaction in an acidic solution. Or it might say under acidic conditions or something like that. Well, first things first, let's figure out what element is being reduced and what element is being oxidized. So let's put charges above everything. Okay, if this is throwing you off at all, okay, don't let it throw you off, okay? What charge does aluminum carry when it's in a compound? 3. Okay, +3. And these are what they always are. Oxygen is always -2, hydrogen is going to be +1. So what are the two elements that are changing here? Aluminum and manganese, okay? Step 1 in this process says, write separate reduction and oxidation half reactions. Okay? First, let's deal with aluminum and watch how I'm going to write what's called a half reaction. I'm going to write aluminum exactly as it appears on the left and exactly as it appears on the right. If it's within a compound, write the whole compound. And there is a little -1 charge up there. I know it's hard to see because it's small. That's my first half reaction. My second half reaction is going to involve manganese, which I'm going to write exactly as it appears on the left and exactly as it appears on the right. Step 1, done. The next step says, for each of these half reactions, it says balance all elements except hydrogen and oxygen. Meaning, don't balance those yet. So what that's asking you is aluminum in balance in this first one? Yes. Is manganese in balance? Okay? Yes. Let's move on. The next step says balance any oxygens using H2O, water. Well, tell me this. On the left-hand side here of this aluminum reaction, how many oxygens are there? 0. How about on the right? 4. So watch how I'm going to balance that out. Are just the oxygens? Is oxygen in balance now in this first one? Yes. Okay. What about for this second reaction? How many waters and to what side should I add them to balance the oxygens? Yes, ma'am.
You should put 2 waters on the right side.
Okay. 2 waters on the right-hand side. Okay. Now, if any of you are concerned at this point of, how can I just put this in a reaction? I mean, isn't that breaking that whole conservation of mass thing? You can't just create mass. Well, I'm not really creating mass here. It said that this reaction was taking place in an acidic solution. So that's implying that there is water there. Water is the solvent, it's present. Okay. So that step is done. The next step says, balance any hydrogens using H+ ions. Okay? Well, you guys tell me, how many hydrogens are on the left-hand side? How many? 8. How many are on the right? 4. So watch how I'm going to fix that problem. again, I'm not creating mass. Okay? Whether you all realize it or not, any solution that has water in it has some H pluses floating around. Okay? What about for this second equation? How many hydrogen ions and to what side should I add them? Melanie?
2 H pluses.
Not 2 H pluses. 4 H pluses on which side? Okay? Great. Now folks, at this point, all of the elements should be in balance. Are they in balance? It's okay. It's always okay just to check. Yes, every element should be in balance. The next step says, balance the charge using electrons. Okay? This is something that may be new to some of you. The reason that this is such a lengthy process sometimes is because you're not responsible for just balancing the elements. You have to balance for charge as well. And here is the thought process. All right, I want you to look at this left-hand side of this aluminum half reaction. Does water have an overall charge? No, it's neutral. How about aluminum? No. This entire left-hand side has an overall charge of 0. The right-hand side, however, is different. Look what I've got. I've got a -1 charge and 4 +1 charges. Add that together, what do you get? +3. Okay? That's what I mean by this is not charge balanced. And here's how we're going to fix this problem. The way to fix the charge imbalance is to, and listen really carefully to what I say here, you are going to add some number of electrons to one side only in order to get both sides having the same charge. Remember that electrons are negative. How many electrons and to which side should I add them? What do you think? 3 on the right is correct. Because each electron carries a -1 charge. Okay? Let's do the same process down in this second equation. Tell me what the overall charge on the left-hand side is for this guy. +3. And how about the right? 0. So how do I fix that problem? What do you think? You got it. Add 3 electrons on the left. Now, folks, the overall goal here is we are going to be adding these two half reactions together. This is a good point in this process where you should just kind of pause and make sure you haven't made any mistakes. First of all, your electrons should always be on opposite sides. If you get to this point and for some reason you see that your electrons are on the right and on the right again, stop and start over because you've made a mistake. They will always come out on opposite sides. Will they always come out to be the same number? No, they won't always. And we'll talk about what to do in that situation. Okay? But the key is, you have to get those electrons to cancel out. Remember we talked about this a little bit before. We're going to be adding these together to make one big reaction, and anything that's identical on opposite sides, you can cancel out. So what do you see that I can get rid of? What can I get rid of immediately? The electrons, gone. Do you see anything else I can cancel out? All right, the hydrogen ions. Anything else? Yeah, I've got water on both sides. I can get rid of both of those. 4 minus 2 is 2. Okay. Anything else? Nope. So now we'll write out anything that is left. The order that you write your reactants or your products doesn't matter. Final answer. Now, I'm going to let you try some on your own, but before you do, I want to give you a hypothetical situation, which you will see in just a moment. What if I got to these two steps and I had 3 electrons here and 2 electrons there? Your electrons must cancel out in full. You cannot have electrons left over down here. So what if they're not the same number? How would you fix that problem? You can't add any more electrons. You can't add anything. What could you do? Yeah, what do you think, Jed? Yes, yes. He's saying, can you multiply these equations? Yes, you can. If I had a 3 here and a 2 there, what's the word? The lowest common multiple of 2 and 3? What do you want to get 2 and 3 to? You want to get it to 6. That would mean I would multiply this entire top equation, all of the coefficients, by 3, and then I would multiply all of this bottom equation times 2, and change all of my coefficients, and then add them together. Okay? So, I want you to try do some on your own. Okay? Let me tell you, numbers 1 and 2 are very much what you will see, are very much like ones that you'll see on a test. Number 3 is a little bit of a challenge. So if you get through number 1 and you feel like, yeah, okay, I got this, try number 3. But 1 and 2 are the big focus here. Try them. Final answer for number 1. Nope. Okay. So let me just say again, numbers 1 and 2, the ones that I have worked out here, these are very much the kind you're going to see on our test next week. If you can handle numbers 1 and 2, you should feel like you're in good shape. Okay? 3 is a bit of a challenge. There is one on the next slide that is like an uber challenge. Okay? Now, guys, there is one last little piece to chapter 4, and it's very, very quick, okay? You'll notice that the instructions for these questions said to balance these in acidic conditions or acidic solution, okay? The very last slide of this chapter says to balance a few of these in basic conditions. Now, does that mean you need to go and memorize a whole new set of rules? No, it doesn't. You will go through, if you were given a basic problem, the exact same steps you just did. The exact same steps, the same order, same everything. There is just one additional step at the end. And I'm going to show it to you using this answer here for number 2. I'm going to use that as an example. So let me move this up, and I'm just going to pull this down so that we're just looking at this one. Okay? If the instructions had said to balance this question, number 2, in basic conditions or a basic solution, that doesn't change anything that I have done here. I would have gone through this exact same process and got down to this step. There is one additional step. Okay? If acids are things that contain a lot of H pluses, what do you think bases are? Lots of OH minuses. So what I would do is, I would get to this step and say, okay, where in this equation are my H pluses? Here they are. If the question says balance in basic solution, I find where these are, and I'm going to add whatever this number is in front of the H plus, the same number of OH minuses to both sides of the reaction. Don't just add it over here, you add it to both sides. And I'm going to rewrite this again. Okay, now guys, what do you get when you put H plus and OH minus together? You get water. How many waters would I get here? 4. Plus 7 that I already have. What's 4 plus 7? 11. Okay, come on computer. 11 H2O. Run out of room. Okay? So, and I'm going to give you, I'm ending a little early because I want you to have some time to practice with these. This would be the final answer if the problem said balance it in acidic conditions. This would be the final answer if that problem were to be balanced in basic conditions. Okay? So, I want you to do a little bit more practice. There's that Uber challenge one. And I'm going to change this. I don't like that problem. I'm changing it. I'm giving you a new one. Okay. So I changed it. I didn't like the one I had up there. I want you to try this one. Try balancing it in basic solution. Remember, the process for the first 9 steps is exactly the same as what you were doing a minute ago. Do not worry about that whole OH business until you get to the very end. Try it.
Did you come up to me and say hi?
Ladies and gentlemen, let me give you a piece of advice on doing a problem like this. Okay? You're going to see these on free response. It's not that they're particularly challenging, it's that it's very easy to make a small mistake. And a small mistake is going to mess up the entire final answer. Okay? My suggestion to you, when you take the test next week, write out as much as you can. Write out, you're going to have plenty of room on the paper. Show me as much as you possibly can on your thought process. Because when I look at your final answer, if I see something different than what is correct for the final answer, I'm going to look back at what you've got for your work. And I'm going to see, did you just make one small addition error? If I can find that one tiny little place where you messed up, you're not going to lose all points. Okay? If I can't tell where you went wrong because you haven't shown your organized work, or I don't know, then you're going to lose more points. So it's to your advantage to write it out in a sort of lengthy way if you can.